Okay, once you have that out, I want you to copy down that example and see how much we remember from yesterday and kind of Science 10 a little bit. Okay? Okay, let's go over this one. So the reason I put one up like this is it's a really short stem of a question, and it doesn't really outright give you anything except the displacement of the bolt. Okay, so we do know that the displacement of the bolt is 6.0 meters, and well, in the direction things generally fall down. Okay, it doesn't outright have to say that, the context tells me that. Now, it says it falls off the roof. It fell. It wasn't thrown. What's its initial velocity? Zero. Okay, if something falls off, it's starting from rest. That's just another one of those context clues that we have to be ready for, right? It wants to know how long it will fall. What's the other piece of information it kind of gave me but didn't?
It gave you the acceleration because when it says it falls, it's implying gravity is pulling it down at a constant rate.
Exactly. And we also assume that this falling is happening on Earth. Okay? Unless you're told otherwise, okay, you can assume that things are happening on Earth and that acceleration will be 9.81 meters per second squared down. Okay, so again, the only reason I put a question like this up there is because I want you to kind of get used to, they're not always going to tell you everything. They're not always going to give you the number. Okay. All right, so that would mean then that this is probably the formula I'm going to want to use because it's what I have. Okay. Since VI is 0, can I use this to find time?
Yes.
Yes. Okay. Because VI times t is 0, which eliminates that t from the equation. And now all I have to do is isolate this t. So I'm going to divide both sides by half of a, and then I'm going to square root. Now I'm solving for t. So that's going to be 6 meters. I'm going to say negative 6 meters divided by 1/2 times negative 9.81. Could I have also just made down positive? Right, there's no change in direction here, so the negative's a little bit redundant, but that's the way I did it. It's going to work out the same either way. All right, so square root of negative 6 divided by 0.5 times negative 9.81. All right, it's going to fall for 1.1 seconds. We have 2 significant digits in the question. Now, another note about significant digits. If you take a number from your data sheet, those are absolute, okay? They are not measured values. Therefore, any number taken from your formula sheet does not contribute to your significant digits, okay? We consider all of those absolutes, not measured values, right? It comes up once in a while when you're using 9.81, okay? If it was, the lowest number, remember it wasn't really the lowest number. It has an infinite number of significant digits. All right. Try that one. All right, so we're looking for the final velocity in this one of a rock that is propelled over a 0.30 meter distance. Okay, so no vector on that. Okay, by an acceleration of 22 meters per second squared. Okay, for a 0.72 second interval. Okay, what formula should I use for this one? Maya, which one?
Displacement equals df t minus 0.5 acceleration t squared.
Exactly. Okay, that's the one I've got everything for. Right? I have time, so that's good. And I'm looking for VF. So what should I move first here?
1/2 a t squared.
Yeah. How do I move it?
Just add it.
Just add it, exactly. So I go d plus 1/2 a AT squared equals VF times T. All right, I want VF by itself. What do I do with T? Okay, now I'm solving for VF. All I have to do is plug in my numbers here. So that's going to be 0.30 meters plus 1/2 times 22 times 0.72 squared divided by 0.72. All right, so final speed, I guess, for that one would be 8.3 meters per second. Okay, and I wouldn't be putting a vector on that because it asked me, oh no, it did ask, what's the final velocity? What can we put on there as a vector that we can be sure of? Plus, forward, yeah, something like that. Other than that, we can't really give anything else. It should probably say, what's the final speed? Because we were never given vectors in this. Even for the acceleration, we weren't given a vector. Okay? All right, so the reason I put that question up is, that's an example of a question that, you know, you got the algebra is probably a little trickier, but the context of the question is simple. They outright say, hey, A is this, and VF is that, and D is this, okay? And they don't make you think at all about the context. Okay? Sometimes I'm going to give you ones that are going to have an easy context, but you're going to have to do a little more algebra, and other times I'll give you one that doesn't require a lot of algebra, but it's a tricky context. Sometimes I'll give you both tricky, because that's how I roll. All right, try that one. So in this one here, we're looking for initial velocity, okay, of a bullet that enters ballistics gel. I don't know if you guys have ever seen this, but on Mythbusters, they used to use this stuff all the time. It looks like Jell-O, but it's much more dense, and it has approximately the same resistance as the human body. So they actually use it in like crime scene investigations, ballistics investigations, etc., to determine like if someone's been shot, at what distance were they shot from, based on how far the bullet penetrates, kind of things like that. It's a good replica for like, you know, human tissue without having to sacrifice obviously people or animals, okay, to the course of science there. So they use it for that, okay. So it slows, it enters ballistics gel and slows at 150 meters per second squared. What do I have to know about that number? It's negative, it's slowing. Okay, for 0.252 seconds. Okay, if its final velocity is 65.2 meters per second. Okay, what does that mean for the ballistics gel if there's a final velocity that's not zero?
It goes through it.
Yeah, right, it's a through and through. Okay, that means the bullet goes all the way through and exits on the other side. Okay, like I said, Mythbusters uses this stuff all the time. They've got tons and tons of episodes where, you know, the bullet goes all the way through the ballistics gel, hits something, and actually comes back in, and they find it's still in the gel, but it's from the return, okay, off of after the ricochet, things like that. So that would be something the gel did not stop it; it just kept going. Okay. All right, so we're looking for VI. Okay, I've got these pieces of information. What's the best formula to use?
The acceleration equals velocity final minus velocity initial.
Right, the one we learned last year. That's the best one here. It's got the stuff in it that I need. Okay, so I'm manipulating this to find its initial velocity. Now this is the tricky manipulation of this formula, right? First thing I want to do is move t over to this side by multiplying both sides by it. Okay, so t is over there now. And then what I do, you don't have to do it this way, but what I do is I add vi over to the other side, okay? Which most people find counterintuitive because now I'm not solving for it, except I will be in a second. Now vi is positive. I'm not solving for a negative number. Now what I do is subtract t times a back over to this side. Okay, now VI is positive, and I can solve for it. So we'll have 65.2 minus 0.252 seconds times negative 150 meters per second squared. Okay, so 65.2 minus 0.252 times negative 150. So I'll be subtracting a negative number. That's going to give me a VI that's obviously larger than 65.2. Okay, this was obviously not a high-powered weapon. Okay, if it only entered the gel at 103 meters per second, it had either traveled a long way and it slowed down, or it hit something else first. Okay, that's not very fast for a bullet. You could almost go and matrix out of the way of a bullet moving at 100 meters per second. Okay. All right. Everybody with me on that? Should we probably use thicker ballistics gel for a test like this? All right. All right. There's no more questions on that one. Okay. Let's try this one here. So we're looking for how far a plane flies. So we're looking for D. While accelerating at positive 4.52 meters per second squared. Okay, from a velocity of 123 meters per second to 300 meters per second. Okay, those would be by default positive because the acceleration was indicated to be positive as well. Okay, what formula am I going to use here? JC, which one?
Just go back.
Oh, sorry, you skipped back. Right. Max, which formula should I use for this one? Which formula should I use? Okay. So I've got A, I've got VI, I've got VF. Okay. And I'm looking for D. Please.
VF squared equals VI squared plus 2a times the distance.
Right, this one. Okay, that's the one that's got them all in. Right, so I'm trying to solve for D here. So the first thing oops, sorry, that's supposed to be squared. I'm going to subtract VI over to the other side. So we'll have VF squared minus VI squared equals 2 times A times D, and then just divide 2A over to the other side, and we're set to calculate D. Okay, so we plug in our numbers here, and we're going to have 300 squared minus 123 squared, okay, divided by 2 times 4.52. Okay, so it's going to travel a fair ways there. Okay. Oh, sorry, I put 103, didn't I? I did. Sorry. Let's try that again. 300 squared minus 123 squared. Makes a big difference. Okay. Divided by 2 times 4.52. Okay, still going to travel over 8 kilometers to do this. But it's going pretty fast. It's not like it takes it very long to go 8 kilometers at the speed it's going. So we would have, we have 3 significant digits there, so 8.28 times 10 to the 3. All right, now here's what I wanted actually out of this question. Do I need a vector on that answer? The question asked, how far will it travel? Did it ask what its displacement or how far and in what direction? How far is distance? Okay, it's just one of those little tricks, but it's one of those things we got to always be on the lookout for. This requires no vector because it asks how far. How far is distance? Like how fast is speed? Okay, if it asks how fast and in what direction, then it wants velocity. How far and in what direction, that's displacement. Okay? Little details, little things. Okay, let's have you try that one. Looking for initial on that. So, what's the initial velocity of a runner? So, looking for VI, okay, who finishes a race at a velocity of 15 meters per second. Now, it doesn't say this, but I have to assume that in a race, you're running forwards. There aren't too many races where you run backwards, especially at 15 meters per second. That would be a neat trick. Okay, so VF will be 15 meters per second forward. okay? If the race was 150 meters long, okay, and took 21.2 seconds. Okay, so what formula should I use here?
What is it, what does D stand for?
Displacement.
Displacement equals velocity final plus velocity initial divided by 2 times time.
Right. Okay, I've got to use that one that doesn't actually have acceleration in it. Okay, now, it doesn't say in here that the acceleration was uniform. We're going to have to assume that. It's the only formula we have that has the stuff we have in it. Okay, so we are looking for VI. What should I do with T? Divide it over. Yep. Okay, equals VF plus VI over 2. All right, what should I do with the 2? Right, I'm dividing by it, I want to. By. Okay, so that's gone. What do I do with the VF? Subtract it. Okay, so I'm going to have 2D over T minus VF will give me VI. Okay, so 2 times 150 over 21.2 seconds minus 15. Right, that should give me my VI. So 2 times 150. Okay, I can't believe I just typed that out. It's 300. Divided by 21.2. Okay, and then add, and then subtract 15 from that. Now this is weird. I got a negative number. Is that okay? Is it pretty small though? Okay. How many of you have ever watched somebody start and starting blocks? Like watch a race where they start and starting blocks. Okay. Do they have a tendency to rock backwards a little bit before they get going? Okay. I know this seems kind of technical, but it actually isn't unreasonable to have a small negative initial velocity, okay? Because people are in blocks and then the gun goes off and they tend to have a tendency to rock backwards slightly, okay? Especially if they've been held in the set position for an extended period, which some starters do. Okay, so not an unreasonable answer. If you got that and you were looking at it and going, that seems wrong, that's okay. Like I would want you to question an answer like that. Okay, but in a strict context kind of a situation, it's not an unreasonable answer. Okay, it's strange, but it's not unreasonable. Okay, I don't know how many of you have printed the workbook. Okay, but I want to do some of the problems from the workbook here for acceleration. Okay, because tomorrow we're going to do our lab. Okay, so I'm going to put, well, I've got those up here right now. So let's say I would like you guys to do right now number 2, 4, 5. 8. 9 and 10. Okay, let's start with those, see how you do. The answers are there in bold, so you can check your work. Right? If you don't get that answer and you're not sure why, then we'll do them on the board. Okay. I mean, obviously, we're not getting all the ones on that sheet done. I'm leaving some. If you want to practice, that's what they're there for. Those are the kinds of things that will be on the quiz on Friday. Okay, there'll be some acceleration problems, some graphing, velocity versus time especially. And then tomorrow, obviously, we're doing our lab. So same as the first lab, at least one person in your group needs that SparkView app on their phone. Okay, we'll just be, running carts down a ramp. Super simple data collection, building a graph. Like if you guys are focused tomorrow, you'll probably get it done in class. Okay, shouldn't be too difficult there tomorrow. Okay, we are going to tie that into some of the things that we talked about with the acceleration formulas. Okay, namely, we'll be looking at this relationship here. Okay, if I have a graph that looks like this, okay, and it's a velocity versus time graph. Let's say I build this tomorrow in Google Sheets, and it spits out for me that y equals, let's say 3.2 times x plus 1.26. Okay? Here's what I want you to ask yourself, because it'll help you with tomorrow and doing the lab report. Okay? If this is a velocity versus time graph, okay, this is B. Agreed? What does B represent on this graph?
The starting point?
The initial velocity.
The initial velocity, starting velocity, starting point, yeah. Okay, so B is going to represent our initial velocity. What would any y value, let's just use that one up there, represent? The final velocity. Okay, obviously any x value, okay, would represent time. Okay. What would the slope of this line represent?
Acceleration.
Yeah. Okay, the slope of this line represents acceleration for this reason. M equals y minus b over x. We just established over here that any y value would be our final velocity. B is our initial velocity, and x is time. I'm pretty sure we've seen that formula before. Okay, and it works just like it does on a position versus time graph. It just calculates velocity there, right? It's change in position divided by time. Other thing to consider, if I wanted to calculate the displacement here, okay, what values do I have for this graph? I know VI. Do I know how long I collected data for? Okay, so I would know time. Okay, since I have this equation, what else do I know? What else do I know? What's the slope represent?
M,
Yeah, what does it represent?
acceleration.
Acceleration. So if I have a velocity versus time graph of data built, okay, and I get it to spit out the equation, I have A, I have VI, and I have T. Could I use some of my kinematics formulas, my acceleration formulas, to calculate displacement rather than trying to figure out all the shapes? Would that be easier, like maybe this one? I have everything in that formula, right? I could easily calculate D, and I'm still only using data off of my graph. Okay, all of it is there for me to use, rather than trying to do geometry. Okay, little things to think about, because those are the kind of things that might end up in your analysis for your lab tomorrow. Okay, that kind of make it go a little bit faster. Okay. All right, questions on that? Does that sort of make sense? Okay. Next week, we're going to start moving into vector addition. So we're going to start doing a bit of trig next week. Okay, so make sure you've got a scientific calculator for next week. Okay, because you're going to need it to do all the sine, cos, and tan stuff that we'll be starting next week. Okay. Now, the last ones I wanted you to do here. Yeah, I wanted you to do the last three, 27, 28, and 29. Let's see if we can do those before the bell.